Hello everyone, myself Professor Chavan. We have started the third chapter from our 11th Science CBSE board for the subject physics. In previous lecture, we have learned about some introductory part for the graph. How we can draw any graph if we have some data or some readings of the two respective physical quantities. And on the basis of that graph, on the basis of that pictorial view, we can say directly how the one quantity is related with the another quantity. Okay, we can give the relation between the two physical quantities with the help of graph easily. Even if we don't have the measurement, also we can give the reading of that particular quantity, or we can give the relation between the two physical quantities. Or if we have the value of any one physical quantity and we have one graph, then we can find out what will be the value of the second physical quantity. Okay, so that is the importance of the graph. This is a very important in terms of the physics. Okay, so we have to find out whether the graphs are drawn for only finding the relation between the physical quantities or not. Okay, so in case of the graph, there is the one term, that is the slope. Okay, so that part we will see today, slope of the graph. Okay, slope of a graph. We know what is the slope. Slope is the tan of the angle represented by the inclined line with respect to the horizontal. Okay, in the graph, what is the slope? Okay, it is the tan of the angle subtended by an inclined line with respect to the horizontal. Okay, that tan of the angle represents the slope of that particular graph. Okay, then if we have one graph like this, suppose, okay, in this, if we have this line, and how to find out the slope of this line? So for that purpose, we have to find out what is the angle, and to find out the angle, we must have to know its x and y coordinates. Okay, so accordingly, if we have to find out the angle of this inclined line with respect to the horizontal, so here is some angle, suppose here is the theta. Okay, and suppose if we draw one vertical line from this, okay, then the tan of the angle, according to our geometrical relationships, how the tan of the angle is given? It is tan of this angle, tan of the theta is equal to what is opposite. Okay, opposite upon adjacent. Okay, opposite upon adjacent. So in this case, what is the tan of the angle? Here, this is the perpendicular drawn from this inclined line on this vertical axis. So here we can say that it is the perpendicular upon this adjacent. This adjacent represents the base of the triangle. Okay, this adjacent represents the base of the triangle. So how we can find out the perpendicular of this triangle? Okay, if we have the coordinates of the x-axis and coordinates of the y-axis, suppose this is the x-axis, this is the y-axis, and if we have the coordinates of this particular, then what will be the coordinate at this point? For that purpose, we have to draw one perpendicular from this point on the y-axis. Okay, we have to draw one perpendicular from this point on the y-axis. Then we will get here the coordinates of the y. Okay, now to find out this total length, how can we find out this total length? For that purpose, the final position minus the initial position. So accordingly, we can find out what is the value of y coordinate here. Suppose this is the y2, then it will be the y1. Okay, it will be y2 and this will be the y1. Similarly, what is the coordinates of the x along this x-axis? This will be x2 and this will be x1. Okay, this will be x2 and at the point of origin it will be x1. Okay, so how we can find out the length of the perpendicular? It is nothing but the final position minus the initial position. So it will be equal to y2 minus y1. Okay, y2 minus y1. Then what about the base? It is also similar, x2 minus x1. Okay, x2 minus x1. Okay, so to find out the tan of the any angle, we have the formula tan of the theta is equal to perpendicular upon the base, and the perpendicular we can find out in terms of the coordinate by the y2 minus y1 upon x2 minus x1. The final position minus initial position upon the along the y-axis upon the final position minus initial position along the x-axis. Okay, so by this way we can find out the perpendicular and base for this. Okay, so accordingly we can find out the tan of this angle, and this tan of the angle is nothing but the slope of the graph is equal to slope of the graph. Okay, the tan of the angle is nothing but the slope of the graph. Okay, so here is the angle theta. Okay, here is the angle theta. So if we draw any line, horizontal line along this inclined line, then at that location there will be angle theta. Suppose if we draw one horizontal at this point, okay, at this point if we draw one horizontal, then here will be angle. How much will be angle here? Here theta. Okay, this will be same as this one. Okay, this will be same as this one. So if we have to find out the tan of the angle at this location, suppose, then in that case we have to draw one perpendicular from this inclined line on this horizontal line. Suppose we draw one perpendicular from this point on this line. Okay, then what is the value of this point, or how much will be the coordinate of this point, we can find out by drawing the perpendicular from this point on the y-axis. Okay, if we draw one perpendicular, so it will be suppose y3. Okay, suppose it is a y3, and what is the value of this point? If we draw here from here, then it is a y, suppose suffix a. Okay, suppose, or if we consider here y4 and here y3. Okay, y4 and the y3. Similarly, we can find out the value of the x coordinate and the y coordinate also. Okay, we can find out the value of x coordinate and the y coordinate. So for that purpose, we have to draw this, extend this line up to the x-axis, and this will be the x coordinate, and from this point we have to draw the perpendicular. So it will be x3 and this will be x4. Okay, this will be x3 and this will be x4. So at this location also we can find out the slope of that particular graph. Okay, at this point also we can find out the slope of that particular graph, and slope is nothing but the tangent of the angle subtended by that inclined line with respect to the horizontal. Okay, it is the tangent of the angle subtended by that horizontal inclined line with respect to horizontal. So in this case, what is the slope? Slope is equal to tan of the angle theta. Okay, because theta will be same as it is making here angle theta with respect to horizontal, here will be theta with respect to horizontal. So what is the perpendicular here? Perpendicular is equal to y4 minus y3. Okay, perpendicular is y4 minus y3, and what is about the base? It is x4 minus x3. Okay, x4 minus x3. Okay, so by this way we can find out the slope of the any graph. Okay, we can find out the slope of the any graph. Now depending on this slope, we can find out the values of the any other physical quantities also. Suppose I draw one graph. Okay, Then this is the one graph. Then if I have to find out the slope of this line, I will go by this same way, the y2 minus y1 upon x2 minus x1. Then if I have to find out the slope of this line, then in that case also I will go by the same way. Okay. Then about in this case also I will go by the same way. Okay. I will draw one perpendicular from any point on this line, and I will draw here one base. Again along this I will draw one base, one perpendicular. I will draw one base, one perpendicular. Okay, draw one base, one perpendicular. So in that case we come to know that as the inclination of the line increases, the slope of the angle increases. Okay, as the inclination of the line increases, the slope of the angle increases, the slope of that graph increases. And how much is the maximum value of that slope? It is equal to 1. Okay, it will be equal to 1, because even if we change the side to this side, suppose we have to find the slope of this line, slope of this line, slope of this line, then what we have to do? We have to draw one perpendicular, we have to draw one base, we have to draw one perpendicular, we have to draw one base, we have to draw one perpendicular, we have to draw one base. Okay, so accordingly, as per the coordinates available with us, okay, as per the coordinates available with us, we can find out the slope of the any graph. We can find out the slope of any graph. Okay, and how much is the value of the any? Tan of the theta, it is equal to 1. Okay, we get the tan of the theta is equal to 1 at which location? When here it is along this vertical line. Okay, when it is along this vertical line, then the slope will be equal to 1. Okay, slope will be equal to 1. So if we consider here it is at the, suppose theta, and here also it is the theta, then whatever the perpendicular we draw from this line, okay, then if we find out the tan of theta in this both the case, okay, in this both the case, when we consider the tan of the theta, for that purpose tan of the, we know tan of the theta is equal to tan of the minus theta. Okay, tan of the theta is equal to tan of minus theta. Means what? If this angle is the 45 degree and this angle is also 45 degree, but if we count this angle from this direction and this angle from this direction, okay, this is the clockwise and this is the anti-clockwise. So if we consider any one angle as the negative one, then in that case tan of both the angles will be same. Okay, this is tan of the minus theta, that is equal to tan of theta is equal to tan of mod of minus theta. Okay, that is, we have to consider it is nothing but the mod of minus theta. Means we don't have to consider the negative sign there. Okay, whatever the value come there, it is similar to the tan of the both the sides. Okay, so if we consider here tan of the theta and the equation has the opposite upon adjacent, then if we take the perpendicular upon base and y2 minus y1 upon x2 minus x1, then here also y2 minus y1 upon x2 minus x1, okay, then in that case it gives the slope of a graph equal to same on both the sides. Okay, it will give us the slope of a graph same on both the sides. Okay, so similarly we are going to represent the number of physical quantities by using our slope. Okay, we are going to represent now. Okay, suppose we have the value of the number of positions and with respect to time. Okay, we have the number of positions with respect to time. Suppose we have position and time values. Okay, this is the x we can say, and this is the time. And for 0 0, then for the position is 1 for the 10 second, 2 for the 20 second, 3 for the 30 second, 4 for the 40 second. Okay, just we are taking for the example. Then in that case, how can we represent this? We have learned this in the previous. Okay, so we can represent this by considering any one quantity along any one. Then if we consider here as the time, and this along it is the position. Okay, then if you consider a time and it is along the position and indicate 1, 2, 3, 4, 5. Okay, time is 10, 20, 30, 40, 50. This is 1, 2, 3, 4, 5. Okay, so this will be the origin 0, 0, and from this if we draw these 2 points, then we come to know that it is the one inclined line. Okay, it is the one inclined line, that is 1 and 10 will get attached here, then 2 and 20 will get attached here, then 3 and 30 will get attached here, 4 and 40 will get attached here. Okay, it will be one straight line. Okay, it will be one straight line. So position is nothing but the displacement. Okay, we know the change in position is nothing but the displacement. Okay, the change in position is nothing but the displacement. So if we have to find out the slope of this graph now, okay, if we have to find out the slope, then what we have to do? We have to consider one coordinate. Suppose we consider the coordinates along at this point. Okay, then at this point if we draw the coordinates, then whatever the angle here theta, this will be equal to theta. Okay, so tan of the angle theta is equal to perpendicular. How much is the value of this perpendicular? It is perpendicular is y2 minus y1. It is y2 minus y1, and base it is x2 minus x1. Okay, x2 minus x1. Okay, so it is what it indicates, the y2 minus y1. Okay, what it indicates, the y2 minus y1, it is nothing but the change in the position. Okay, it is the change in position. And this is the change in time. Okay, we have the change in position upon change in time. Now we have learned one quantity. What is the change in position upon change in time? What is the change in position upon change in time? What is the formula for the change in position, the change in the displacement per unit time, or change in the displacement per that particular time period? What is that quantity? Which is that quantity? It is the velocity. Okay, it is the velocity. So we can write here it is nothing but the velocity. Okay, we can write here it is nothing but the velocity. So we can say here that the slope of the graph, position versus the time, gives us the velocity. Okay, the slope of the graph drawn for the position versus the time gives us the velocity of that particular time. Okay, the slope gives us the velocity of that particular time. So we can write here tan of the theta is equal to velocity is equal to slope of a graph. Okay, so in this case the slope of a graph of position versus the time gives us the velocity. Okay, means the two physical quantities combinedly gives us the third quantity. Okay, the two physical quantities combinedly gives us the third quantity. Means the position, we have the particular displacements, we have the readings of the particular displacements, and we have the readings of the time. Okay, then in that case we can find out the third quantity also. Okay, so note down this third advantage of the graph, that if we know the two physical quantities, the relation between the two physical quantities, and if we draw a graph of that two physical quantities, and if we take the slope of that graph, then we will get the third quantity. Okay, we can get the third quantity. Okay, similarly, if we have the values of the, we know what is the force. Force is nothing but equal to, okay, example, if we take the force is nothing but equal to mass into acceleration. Okay, therefore we can write that the acceleration is equal to force upon mass. Okay, we have this formula, acceleration is equal to force upon mass. Now for this, if I draw one graph, in that y2 minus y1 I have to be the force. So along the y-axis I have to consider the force, and mass along the x-axis. Okay, it is the mass. Okay, now if I got a graph of this like this, okay, if I got the graph of the force versus mass, then if I find out the slope of this, okay, if I find out the slope of this by drawing one perpendicular and one base, okay, if I find out the slope of this graph, then which quantity I got? Which quantity I get? I get the acceleration. Okay, I get the acceleration, because in this case slope is equal to force upon mass. Okay, in this case the force is equal, slope is equal to force upon mass, and we know what is the force upon mass. Force upon mass is equal to acceleration. Okay, force upon mass will give us the acceleration. So from this graph we can find out how much amount of force when we apply on any mass, how much amount of acceleration we get. Okay, how much amount of force when we apply on any mass, then how much amount of acceleration we get, and how much will be the acceleration we can find out by using this slope. Okay, we can find out by using this slope. Okay, if we know these two values, we can find out the third value. Okay, and this graph will represent the acceleration. Okay, this graph will represent the acceleration. So this is also the one important in the slope of a graph, that if we know the two physical quantities and there is some relation between two physical quantities, then we can find out the third physical quantity by knowing the slope of the graph. Okay, by knowing the slope of a graph. So this is also one important use of the slope of a graph. Okay, suppose we have the two bus traveling some particular distance. Okay, if we have the two bus traveling some particular distance, and we have to find out that which bus is having the maximum velocity. Okay, which bus is having the maximum velocity, then what can we do? We have the readings of the displacement and time for both the bus. Okay, then we can draw a graph. Okay, we can draw a graph of displacement versus this time. Okay, we can draw this graph of displacement versus time for both the bus. Okay, we have the reading. Suppose the first graph, first such a line will come as like this. Okay, for the first bus the graph will come like this, and for the second bus the graph will come like this. Okay, for the bus A, for the bus B. Okay, for the first bus the graph is coming like this, and for the second bus the graph is coming like this. Then which bus is having the maximum velocity? Can we find out? Yes, we just have to find out the slope of that inclined line. Okay, the tan of that inclined line with respect to the horizontal, that will give us the slope. And which line having the maximum slope, which line gives us the maximum value of the slope, that line will have the maximum velocity, because we have find out here that tan of the theta, in case of the change in position upon change in time, it will give us the velocity, that is the slope of a graph. Okay, so which bus is having the maximum velocity? Suppose we draw here one base, one perpendicular, one base, one perpendicular, and if we find out the slope of both the bus, okay, theta 2 and theta 1, okay, if we find out the slope of both the bursts, then what will happen there? If we find out the slope of both the bursts, then we come to know that you can just look at this and you can tell me, okay, that is the one use of the graph, that by only looking at that graph you can predict what will be your answer. Okay, you can predict what will be your answer. So look at this, which line is having the more slope? The line B. Okay, line B is having the more slope than the line A. So from this, if we go for the calculation by the actual reading, and if we get the lines like this, so we can say that the bus B is having the more velocity than the bus A. Okay, from this we can say that the bus B is having the more velocity than the bus A. Okay, so this is the use of a one graph, that only looking at that graph also we can tell which value will be there, or what will be the count, or what will be the relation between the two physical quantities. And as we have learned recently that the two physical quantities combinedly can give the third physical quantity, like change in position upon change in time gives us the velocity, the change in force upon change in mass gives us the acceleration. Okay, so like this we can find out the third quantity also. Okay, so we see one more example about the slope. Suppose we draw a graph of a displacement versus time. Okay. Displacement is denoted by x and time in t. Okay, there is the displacement. This is the time. Then if we got one straight line, if we got one straight line, and if we have to find out the slope along this straight line, then if we consider the same intervals here, okay, 1, 10, 20, 30, 40, 50, 1, 2, 3, 4, 0, 0. Okay, got here. Okay, so if we have to find out the slope of this graph at each and every coordinate, then we have to go for its angle. Okay, how much is this? It is 10. This is 1. Again at this point it is 10. This is 1. Again at this point it is 10. It is 1. Okay, again at this point it is 10. It is 1. Okay, so if we find the slope at each and every coordinate, then we come to know that the slope at each and every coordinate is same. Okay, when the slope and each and every coordinate is same, then in that case we can say that that body is moving with the uniform displacement. Okay, that body is moving with the uniform displacement, because when it covers the 10 seconds, in the 10 seconds it covers the 1 meter, in 20 seconds again it covers the 1 meter and goes to 2 meter, in a 30 second it goes to the 3 meter. Okay, so at a regular interval of time, if we take the readings, and we come to know that the distance also coming as the same. Okay, the interval of the time is same as well as the interval of the distance is same. Okay, here the interval of distance is 1 for each step, here the interval of time is 10 for each step. Then we come to know that along this line, at any point we count the slope of that line, it is same. Okay, not just at the coordinate, even if we find the slope at this point, okay, the slope of at this point also equal to same. Okay, the slope at these points also same. Okay, that is, we come to know that it is the uniform displacement. Then such type of motion is known as the uniform displacement, or we can say that it is the uniform velocity. Okay, so whenever we get one straight line curve for the any graph of a displacement versus time, that graph will represents the uniform displacement. Okay, that graph will represent uniform displacement, and any point along this inclined line we represents the uniform velocity. Okay, so in this case we can write down it is the graph of uniform displacement or uniform velocity, because slope at any point along inclined line is same. Okay, because the slope at any point along the inclined line is same. Okay, so graph of uniform displacement or the uniform velocity we get if it is the one straight line. Okay, it is one straight line, that is in the graph of displacement versus time. Okay, so if we get one straight line, it represents the uniform displacement or the uniform velocity, because at any point along that inclined line, if we find out the slope, it will be same. Okay, it will be same. Now if we consider the another graph of the displacement versus time, okay, we find out the graph of displacement versus time. So in this case it is the x, it is the time t. Okay, then if we draw the 1, 2, 3, 4, 5, 6, 10, 20, 30, 40, 50, 60. Okay, so if we join all the respective coordinates along this graph, if we draw the readings with respect to reading, if we draw the graph, then if we get the graph like this, suppose from this point the graph will be like this. Okay, so if we find out the slope at any point along this graph, then for that purpose, okay, we have to take one line here. Okay, suppose at this point, if we find out, we have to draw this line, and from this you have to draw one perpendicular. Suppose at here we have to draw one perpendicular. Okay, then if we find out the respective value of the slope at any point along this line, then we come to know that if here is the this is the 0.8, then this will be 3. Okay. Suppose this is the 0.5, then this will be 10. Suppose this is the 0.7, this will be 15. Okay, so if we find out the slope, then we come to know that slope at this position, slope 1, this is the slope 2, this is the slope 3. Okay, we come to know that the slope 1 is not equal to slope 2 and it not equal to slope 3. That is what? There is the change in the displacement with respect to time at each and every point. Okay, at each and every instant of time there is the change in the displacement. Means what? The velocity always goes on changing. Okay, the velocity always goes on changing. That's why we are not getting the same value of slope here. Okay, we are not getting the same value of slope here. So in that case we can say that along this graph at each and every point the value of the displacement changes with respect to time. Okay, so value of the displacement changes with respect to time. So if we find out the respective value of the displacement with respect to that particular time period, we come to know that each and every instant of time the velocity also changes. Okay, each and every instant of time the velocity also changes. Then in that case we can say that as the velocity at each and every point along that graph changes, we can say that this graph represents the acceleration. Okay, this graph represents the acceleration. So we can write down here it is the graph of acceleration. Okay, it is the acceleration graph, or we can say that non-uniform motion. Okay, non-uniform motion type of graph represents the acceleration graph. Okay, non-uniform type of graph will represents the acceleration graph. Okay, suppose we have another type of graph like suppose I draw here. Suppose it is a one xt curve. Okay, it is the xt curve, and I am having the graph like this. Okay, I am having the graph like this. Then from this graph, what you can predict? What you can predict? I will give you one example. Okay, I will give you one example from this graph. What you can predict? Suppose you throw a ball in a upward direction. Then what will happen? As the time changes, that ball will also get displaced more and more. Okay, with respect to time, the displacement of the ball also increases rapidly. Okay, displacement of the ball also increases rapidly. But in that case, what will happen after some time? That displacement goes on decreasing. Okay, after some time, what will happen? As its velocity decreases, its displacement also goes on decreasing, and after some time at this point it is not able to do any displacement. Okay, it is not able to do any displacement. So at that time its velocity also equal to 0. But this graph is showing you the change in velocity with respect to time. Okay, this graph is representing you the change in velocity with respect to time, because as the time changes, the displacement also goes on changing, and each and every point on this graph represents the change in velocity. Okay, if we count the slope at this point, okay, it will be different. If we count the slope at this point, it will be different. If we count the slope at this point, it will be different. Okay, so at each and every point we will get the different velocities. Okay, so each and every point, each point on the line on the graph gives different velocities. Okay, so each point on the line gives a different velocity. So we can say that as the velocity are changing with respect to time, this is also the one acceleration graph. Okay, this graph is also representing one type of acceleration. But if you notice this graph, what you can understand? If you look at this graph, what you can understand that initially it is having the maximum velocity. Okay, here it is the maximum slope, here maximum slope, then here slightly low slope, then here slope decreases more, and at this time here is no any slope. Okay, at this point here is no any slope. So as the ball goes some displacement with respect to time, it is losing the velocity. Okay, it is losing the velocity. So we have learned one term in which the velocity is decreasing. Okay, we have learned one term in which the velocity is decreasing. So what is that term? It is the retardation. Okay, if the velocity or the speed increases with respect to time, it is the acceleration, and if the velocity decreases with respect to time, it is the retardation. Okay, so this graph represents us this graph represents retardation. Okay, different velocities. As velocity goes on decreasing, okay, as the velocity goes on decreasing, this graph represents the retardation. Okay, have you understand the example of a ball thrown in a upward direction? So initially it will get thrown up in a very high velocity, but as it goes high, its velocity goes on decreasing, and at some particular time it will have the zero velocity. Okay, it will have the zero velocity, and at this point it is not able to do any displacement. Okay, so that's why the velocity goes on decreasing, and it represents the retardation. So this graph gives us the retardation. Okay, suppose one more graph if we draw. Okay, one more graph if we draw. Suppose you are going on a bike, and you are passing from one bus stop. Okay, you are going on one bike and you are passing from one bus stop. Then from this some distance, suppose from the 100 meter, you look at that bus stop, that one of your friend is standing there waiting for the bus. Okay, and you are going with a high speed. Okay, you are going with a high speed. Then at that time, what you are doing? You are decreasing your speed and reaching at that point of bus stop. Okay, so initially you are going with the high speed, but as soon as you look at your friend, you are decreasing your speed, you are decreasing your acceleration, and you go to that bus stop and stop there. So at that time, how can we draw that graph? How can we situate this situation? How can we draw the situation with respect to the xt curve? Okay, this is the one application where we can use this. Okay, how can we draw that particular graph? Okay, initially it is away from me. Okay, you are away from that your friend. So from where to start the graph? Okay, from where to start the graph? At the 0? No. Then at some particular instant of time, you are away from the friend. Okay, so you can draw this like this is the xt curve. Okay, so initially this is the 0, 1, 2, 3, 10, 20, 30, 40. Okay, 1, 10, 20, 30, 40, 50. Okay, it is in a meter, it is in a second. Okay, so this is the displacement and this is the time. So in this case, how can you draw that graph? You are initially away from the friend, so you can draw this graph starting from the initial position. So suppose you are at the 50 meter distance from your graph, from your friend. Okay, so look at this point. Then at the 40 you will reach up to him. Okay, then at the 30, as the time passes, okay, you will reach up to your friend. Okay, you will reach up to your friend, and in this case, what is happening there? You are reaching up to your friend after some time interval, and as well as your speed also, your velocity also goes on decreasing. So in that case, this is the example of which? Acceleration or retardation. If you take the slope of this graph, then initially here slope, so this slope you have to find out. This slope you have to find out. Okay, so if you look at this graph, what you can understand, that the velocity, the slope of this line goes on decreasing, that is velocity goes on decreasing. Okay, but what is the initial case? That initial displacement is more and the displacement is goes on decreasing. Okay, in this case the initially is rapidly displacement is there. Okay, initially rapid displacement is there, and now in this case there is the rapid change in the displacement in the downward direction. So that's why here the velocity goes on decreasing also, and this is also the case of retardation. Okay, this is also the case of retardation. So from this graph also you can get the idea of the how you can reach up to your friend. Okay, so this is the graph of retardation. So such a number of types of examples you can take in our day-to-day life also. Okay, number of types of examples we have. Suppose we take the one example of a school. Okay, suppose in a school if our school out time is 3 p.m. and one student is reaching his home at the 3:40 and another after leaving from the school at the 3 p.m. and one student is leaving from the school at the 3:10 p.m. and reaching the home at the 3:30. Okay, then which student is having the maximum speed to reach the home? How can you find out? How can you find out which student is having the maximum speed to reach the home? Both have to go the same distance, that one has to both have to go the 4 kilometer distance. Okay, so in that case if you draw this, if you have the readings, okay, so this is the 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer. Okay, this is the 3 p.m. and 0 kilometer. This is the 3 3.10, 3.20, 3.40, 3.30, 3.40, 3.50. Okay, suppose both have to reach up to this point. Suppose both have to reach up to this point. Okay, then the one student left the school and reached this point at the left the school at 3 p.m. and reached this point, suppose here. Okay, reach this point after leaving the school at 3 p.m. and another student leaves the school after 3:20, means after the school he meets his friend, and then he go to some hotel and then he leave to go to his home. Then it will take some 20 minutes, and also in that 20 minutes he reach to the home in the okay, he reached to the home at the 3:50. Okay, both reach the home at the 3:50. Both are having to cover a 4 kilometer distance. Then from this, by looking at this graph, can you tell me which student is having the more speed? Okay, which student is having the more speed to reach the home? Okay, you can find out this by, if you calculate the slope, if you calculate the slope along this line, and if you calculate the slope along this line, you come to know that which line is having the more slope. You have the readings, and from that readings you are drawing this graph. So which line is having the more slope? Okay, so from the calculation or by the observation also you can get the idea that the second student, this B student, is having the more slope. Okay, the B student is having the more slope, so we can say that the B student will reach the home with more speed. Okay, the B student will reach the home with the more speed, and the A student will reach the home with some uniform speed. But once he left, he reached the home with the higher speed because it is having the more slope and it is having the less slope comparatively. Okay, so such a type of examples, a lot many application oriented examples are there for which we have to draw the graphs. The lot many physical quantities are there for which we have to draw the graph, and from that we have to find out the 1/3 physical quantity. Okay, if we know the graph, if we know the readings of the two physical quantities, we can also find out the relation between them, and if their relation is going for the third physical quantity, then we can find out the third physical quantity also. Okay, so like this we are having the number of graphs. Okay, as per the quantity changes and there is some relation between the physical quantities, we can draw that particular graphs. Okay, so like this, if we draw one combined graphs for all the graphs we have studied today, that we'll take one graph only. Okay, within one graph I will show you. Okay, we will draw the xt graph. Okay, this is the x and this is the t. Okay, this is the displacement and this is the time. Okay, so if we get one straight line graph, okay, if we get one straight line graph, then this straight line graph will indicate which quantity? Remember, straight line graph indicates uniform motion or the uniform velocity. Okay, this indicates the uniform velocity. Okay, uniform velocity. Okay, if we get the one curve, then if we get the one curve, then it is the accelerated motion. Okay, it is the accelerated motion. Okay, it is the accelerated motion. Then if we get the curve like this, then in that case it will represent the retardation. Okay, so this will represent the retardation. Okay, this will represent the retardation. Then if suppose we throw a ball in an upward direction and it gets stuck at that particular height. Suppose we throw a ball and it will remain get stuck at the terrace, then how can we draw the graph for this? The ball will be at rest at some particular height after crossing some displacement. Then how can we draw that? Okay, the ball is at rest at that position, so the ball is having some displacement from our position. Okay, from our position the ball is at some height, so we have to indicate that height also we have to indicate its position, either it is in moving or it is at rest. Okay, so for that purpose, suppose we throw a ball at some particular displacement and after reaching that it will get stuck there, then we can indicate it by suppose one straight line, means it is at rest. Okay, it is at rest. We throw a ball from this origin, from me I am throwing a ball, it will get up to some displacement. Okay, and at the displacement it remains as it is because it gets stuck there. Okay, so how to indicate the motion of that ball? It is at rest now, so we can indicate that by using this straight line. This straight line means there is no any motion now after completing some displacement. Okay, so you can remember this all the four patterns of the graphs for the xt curve. The first straight line indicates the uniform motion or the uniform velocity. This curved line indicates the accelerated motion. This curved line indicates the retardation motion, and this straight line will represent the motion. There is no any motion by that object, that is it is at rest now after completing some displacement. Okay, so there are so many graphs we have to draw in our further studies, because from the graph we will get the easy understanding for the relation between the two physical quantities. Okay, so that's why the knowledge of the graph is very important in terms of the physics. Okay, so this is about the graph and the slope of the graphs.